There have been tremendous advances in the field of fertility preservation within the past 20 years. In my talk, I will be taking the audience through these advances. To name a few, we have generated many options for women, particularly those who are facing ovarian failure due to medical treatments. One of those options is ovarian cryopreservation and transplantation. The clinical work, the success of the clinical work really is based on earlier basic studies in the laboratory. Currently, ovarian transplantation has reached certain success rates that make it quite acceptable as an option for fertility preservation, but there's still room for improvement. In our laboratory, in our translational work, we have made some improvements on the technique, utilizing agents that enhance neovascularization of grafts, as well as advanced surgical techniques like robotic surgery, and that resulted in significant improvements. And with that, currently the success rate of ovarian transplants is around 30 to 40%, but with these new approaches expected to improve further. Egg freezing also has improved significantly with new vitrification techniques. This is no longer considered an experimental approach. We have also developed ovarian stimulation techniques for women with estrogen-sensitive cancer using aromatase inhibitors, and we have shown that more than 50% of the women using these techniques can preserve their fertility. And the children born using these techniques are healthy. Doing ovarian stimulation with these approaches do not increase the risk of breast cancer in these women, even among those with BRCA mutations. And finally, one of the most interesting side observations leading to probably a paradigm-changing finding in ovarian aging is we've noted that in women with BRCA mutations undergoing ovarian stimulation, they tended to produce fewer eggs in response. This led to a series of basic and translational studies and showed us that BRCA being a DNA double-strand repair break pathway gene, and that is involved in DNA repair. Using women with BRCA mutations, BRCA mutant animal models and laboratory work, we've shown that DNA repair pathway might be very important in ovarian aging and potentially when women may experience menopause, and this evolves as a target to potentially manipulate ovarian aging and preserve fertility by enhancing oocytes' ability to fight genotoxic stress.